can see here, where I put my face in front of the camera, you can see it says today, and the solenoid lock unlocks for me. It also works if I have my mask on. You can see it says today, and the solenoid lock unlocks for me. Let's say Mr. Elon Musk walked up. You can see it says unknown because he is not in my customer database, and the solenoid lock remains locked. Let's say Mr. Bill Gates walks up. You can see it says unknown because he's not in my customer database, and the solenoid lock remains locked. I used a program called encodefaces.py to store any face encodings and locations from the dataset into a .pickle file. In the main program, which includes the solenoid lock, I open the .pickle file and read and compare the face encodings. Then we initialize the solenoid lock. We read the frame, resize it, and convert it to grayscale to detect it. And we also detect the faces. We put boxes, and we take the matches and compare the faces.
If Bill Gates wanted to steal a package from the delivery robot that was addressed to you, and he had a printout of your face, what do you think would happen? Have you thought about how you might deal with that situation?
We can add more sensors to see if it's the actual person.
The icebreaker. Our robotic solution to the problem of freezing pipes has a temperature sensor to measure the temperature of the water pipe. If it detects below freezing temperatures, it will send a signal to this Arduino board. The Arduino board will supply power to this eco-friendly heating pad using a MOSFET transistor. The pad will warm the water that would be inside the pipe to above freezing, which prevents it from expanding and causing the pipe to burst. The device also has an LCD display. Additionally, the device utilizes an H206 Bluetooth module that allows the device to interface with an app. The heating pad is currently active and activate and deactivate the device. Finally, if manual control is not taken, conditionals are used to determine whether the heating pad should be on, based on the pipe's temperature.
The icebreaker can be installed on exposed pipes as well as pipes located inside walls. To show you how the icebreaker can be placed on the interior pipe, our team created this prototype. The device can be mounted behind walls by simply cutting into the drywall and installing this access panel, which can be found at any Menards or Home Depot.
In robotics competition, one of the biggest challenges is trying to figure out where your robot is relative to the surface. I built and programmed this prototype, which uses two optical computer mice to tell where the robot is in real time. I also programmed the graphical interface as you can see on the screen. The first thing I want to demonstrate is starting at a known position at a known orientation, home base. So if I take it and I move it around, you can see it knows where it is on the screen. Now if I do a bit of a spin, you can see it shows the orientation, but I'm going to put it in the middle of the table and put it at a bit of an angle and reset the position. It's at an unknown position and an unknown orientation. So now as it goes along, and maybe it goes along this edge a little bit, and now the more edge events it gets, the better. And now if you go to another edge, it'll start adjusting the position a little bit better. The more edges you go to, the more it will adjust. This really shows the effectiveness of the correction. This innovation has exciting potential in revolutionizing the autonomous navigation.
We hope you have enjoyed our dance. You must be curious, how about I turn on the program with Liz? Let me show you. And we also did a marble test. And put in one marble, not good. Put in 5 marbles, good. And the touch sensor one is flat. It will send message to the robot. Music plays and robot start to dance.
We are Visual Music Theory, the new side of the music.
We present the laser guitar.
It's a brand new instrument that functions with a MIDI synthesizer that sends note commands and also can send control changes like sound effects. It also works with serial communication devices like this Bluetooth module, the MIDI synthesizer itself, and a TFT Next-Gen display. Music.
This is what you're doing today. Today you're doing what's called shape measurement. So your robot must determine the area of a rectangle that will be randomly placed on a white playing field. For the challenge this evening, is robo multiplication. Okay, so your robot must scan a playing field and compute the product of two operands.
Go.
Are you all set? Videos submitted? So we get an accurate reading.
We, the tech sisters, have developed 3 innovations to help restart normal life safely. The first is to help improve temperature. Someone with a normal body temperature comes before the screener. It will allow them to enter the building. When someone with a fever comes before the screener, the PIR sensor will detect movement, the thermal imaging camera will take the thermal scan, and will alert them to return home and seek medical attention.
You have a time of your temperature. Please go home and consult a doctor.
We use Python to program this on a Raspberry Pi. The next innovation is to help improve basic protection. We have built the protection helmet. The helmet has a fan at the top to create positive air pressure. This will only allow filtered air to come into the top while not allowing any unfiltered air to be breathed in. The helmet also acts as a social distancing monitor with ultrasonic sensors at the front and back to measure distance. Our third and final innovation is simple, inexpensive, non-invasive ventilation. The inhalation cylinder will draw in fresh air and then provide it to the patient. The exhalation cylinder will extract the exhaled air and push it through hot water kept at about 56 degrees centigrade to disinfect.
How we broke this circle. Real-time oxygen regulation supplies the exact quantity of oxygen that baby needs. With continued monitoring during the whole treatment, we help medical staff react in time and indirectly reduce the amount of work for them. In addition, data recording gives medical staff data-driven diagnosis and help them develop a more accurate oxygen therapy protocol. To understand how it works, the oximeter, to acquire the signals, we started creating our oximeter basing on the functional of a real oximeter. After having that, we put our device can work in 2 ways, by simulations or with the real cases, with the data acquired by our oximeter.